y is equal to the cotangent of x by remembering that the cotangent of x is the same thing as, hopefully we remember that one of our identities we learned that is that tangent is sine over cosine. So if cotangent is reciprocal, that means it's going to be cosine x over sine x. Where, remember, we can't divide by 0, so sine of x cannot be 0. So what I want you guys to think about is, if I have my unit circle, can you guys tell me which coordinate is sine x or y? The y. So do you guys agree that y is 0 here and here? Right? So this coordinate I could label as 1, 0 on my unit circle. This coordinate is negative 1, 0 on my unit circle. Okay? Do you guys agree this is 0 radians if I don't move? If I move halfway around the circle, how many radians is this? Pi, right? And if I kept going, this would be 2 pi. And if I kept going, that would be 3 pi, 4 pi, 5 pi, and so on. If I go backwards, this would be negative pi, negative 2 pi, negative 3 pi. That's bothering me that it's lagging, but it's okay. Do you guys remember how tangent had that restriction about it being odd? Cotangent doesn't, because this is just 0 pi, 1 pi, 2 pi, 3 pi. What type of numbers are all those numbers? They're integers, okay? So that's something to keep in mind. So sine of x is equal to 0 when x is equal to negative 2 pi, negative pi, 0, pi, 2 pi, and so on. So if we know that, that's going to help us draw a tangent pretty easily. So just go ahead and label the graph how I'm going to label it right now. So see if you guys remember, what was the period of tangent? How long did it take to complete one cycle? Pi. So you guys agree cotangent's the reciprocal, right? So cotangent will also have a period of pi. Okay, so that's easy to remember. If you remember tangent, then you remember cotangent. Okay. Do you guys remember that our tick marks, every tick mark was worth pi over 4? Okay, so cotangent, same thing. We're going to use that as a guide. But now that we know this, remember we can't divide by 0. So that means what's going to happen on the graph at all these values? What? You don't know? There's going to be vertical asymptotes. Good. So it's going to be vertical asymptotes. Is that what you said? Okay. There's going to be vertical asymptotes at pi, 0, and negative pi. And if we kept going, there'd be more. So I'm going to go and sketch those in. Now, how are we going to graph this? Remember, tangent was like a little S-shaped graph? This is where you guys all say, yeah. Yeah. All right, cool. So tangent looks something like that, right? Since cotangent's the reciprocal, it's literally the same thing, but just upside down. So instead of it being negative 1, 0, 1, it's going to be 1, 0, negative 1. And literally just be the same curve, just upside down. That's easy. And then same thing. Since it repeats 1, 0, negative 1, do something like that. Cool. For cotangent, we don't have to worry about the asymptotes being odd or even like tangent because this is just negative 1 pi, right? 0 pi, 1 pi. So the way that we write our domain then is a domain is all x where x cannot equal, the asymptotes occur at every pi. So I'm going to say x cannot be k pi, where k is, I already heard it, what type of number? An integer. And if any of you guys ever go on to study math in college, there's actually a way to write this without words too. You guys want to see? So k is what we're talking about, right? It's within a certain like number family. This symbol means within. And then integer, what letter would you guys think integer would be? I? Well, obviously it's Z. I have no idea why it's Z, but that's the math symbol for integers. And you draw it kind of like, I don't know, it looks all fancy, like comic booky. That means K is an integer. That's what that means. Isn't that weird? So yeah. Yeah, at a certain point, like, people are like, oh, you must love math because you're majoring in math. I like this stuff. After my first year, after Calculus 3, it was all homeworks where it's all symbols. So the last 2.5 years were tough. But I survived. And here I am. All right, range. Still all the numbers. Hopefully I didn't scare any of you guys away from majoring in math. If you're thinking about majoring in math, make friends in your program and do your homework. Study. Don't be afraid to ask your professor questions. Your professors will have office hours. Go to their office hours if you guys need help. Okay. So let's go ahead and fill in this box. All right, so domain we just wrote down. We're gonna write it again. Forgot to do this. This represents one period. So on your graph, just label that. This represents one period. And remember the period is pi. So the domain we said is all x, where x cannot be k pi, where k is an integer. The range is all real numbers. Just like tangent, cotangent is also an odd function. period is pi. X-intercepts, do you guys notice something about all the x-intercepts? What do they have in common? Do you guys see how they're all pi over 2's? What type of numbers are in the front of each of the pi over 2's? Do you guys see how they're odd numbers? So I'm going to say the x-intercepts occur at every odd pi over 2. Vertical asymptotes will occur at every x equals k pi, where k is an integer. Cool. All right, so let's graph a cotangent function. All right, so question, is my period going to change in this problem? I see some nods and I see some like scared stares. Yes, the period's going to change. The way that you know that is there a number right in front of the x? Yes, if there's a multiplier right in front of the x, that means that it's going to change, okay? So this is our omega, okay? If this was a sine or cosine graph, do you guys agree this would be our amplitude? Okay, all this is in this graph though is just going to be a vertical stretch, right? So we'll deal with the two later, but our period's going to change, so let's figure out what it's going to be. So this is our omega. So the period, okay, the formula for period is the regular period for the function divided by omega. What's the period normally for cotangent? Pi. So it's going to be pi divided by 3 in this case. Okay, just like for sine and cosine graphs, to figure out the scale, what do we do with that number? Divide by 4, good. So our x scale is just going to be pi over 3 over 4. And if I simplify that, I'm going to get pi over 12. Okay. So I know we haven't written down an actual table yet for cotangent. We're going to do that right now. But we're going to use the regular cotangent table to help me build a table for our new function. So if I want to graph one period of this, remember, where do our asymptotes occur at every what? Pi. So what would be a really smart value to pick first? 0. Okay, so I'm going to start with 0. And then what are we going by on cotangent and tangent? Pi over 4. Good. So pi over 4. pi over 2, 3 pi over 4, and then pi. So we know there's asymptotes here and here. And then if this helps you guys, if you guys just kind of think about what these graphs look like, you guys agree cotangent looks like that, right? It's an upside down version of tangent. So what's going to go here then? Positive 1 or negative 1? Positive 1, right? Because it's above the x-axis, so it's going to be 1, 0, and then 1. Okay? Negative 1. I was just making sure you guys paying attention. Okay. Now, to graph the new function. So your professor in this class is a really nice guy, and he's not going to make you guys shift left and right. So if we started regular cotangent at 0, that means we can start our new function also at 0, but our scale is going to change because our period changed. So I'm going to keep going by pi over 12s until I get to this number. Does that make sense, guys? So if I add another pi over 12 to pi over 12, do you guys agree that'd be 2 pi over 12? And then what's 2/12 simplified? Pi over 6. So this is 1/12. This is 2/12. So the next one would be 3/12. 3/12 is the same thing as pi over 4. If I add another one, that would be 4/12, which is the same thing as 1/3. So pi over 3. So this represents 1 period. Okay. To get the y's, what's the only thing do I have to do to get the y's? Multiply by 2. Good. All right. So if I have an asymptote here and I double it, is it going to change? Nope. Okay, my asymptotes are still going to be the same. First and last values of my period. Okay. So then if I just double the rest of the numbers, I'm going to get positive 2, 0. Okay. All right. So let's go ahead and sketch this. All right, so we have an asymptote right here. Asymptote right here. And then at pi over 12, we have 2. Pi over 6, we have 0. Pi over 4, we have negative 2. So our graph should look something... I missed again. That's better. Something like that. How are we doing, guys? Good? We tired of graphing yet? We're almost done. We have one more section of graphing, and then we'll pause until chapter 5. Chapter 5, we'll graph snails and roses, and it's so much fun. It's so much fun. We really will graph snails. That wasn't a lie. Domain. So do you guys agree asymptote, right? Asymptote pi over 3. If the period is pi over 3, then every pi over 3, there's going to be an asymptote. Does that make sense? So when we wrote our original domain, this meant that the asymptotes occurred at every pi. So since we know that the asymptotes are going to occur at every pi over 3, then my domain is going to change. My domain is going to be all x such that x cannot be k pi over 3. I'm going to highlight my little asymptote and then highlight this so that way hopefully you guys, when you guys are studying, you guys make that connection. Okay? Where k is still an integer. Range is still all real numbers. Okay, questions? Are we comfortable? Are we comfortable before we get uncomfortable? Because it's about to get kind of weird. Well, these whole graphs are kind of weird, right? They're going to get weirder right now. Okay, so we've graphed so far sine, cosine, tangent, cotangent. We still have 2 more to graph. Cosecant and secant. Story time. Thank you so much. So to graph, y is equal to cosecant of x, remember that the cosecant of x is the same thing as 1 over the sine of x. So we've talked about this already today. What other graph has sine on the bottom? Cotangent, right? Cotangent is cosine over sine. So that means that cotangent had asymptotes everywhere sine of x is 0. So guess what? This graph will also have asymptotes. Okay, so this means that the cosecant graph will have vertical asymptotes. Good morning. Thank you. Let me make sure they're here. Thank you. Oh, actually, he's not in this house.
Oh, okay, thank you.
So see if you guys are paying attention. Where does sine of x equal 0? At every what? Pi. Oh. All right. This is the wrong class. One.
Oh, my bad.
There you go.
Yeah.
At every pi, right? All right, so before we worry about drawing asymptotes, I want you guys to think about, we know what the sine graph looks like, right? So what we're gonna do first is we're actually gonna graph the sine function, because this will help us understand what it means to graph cosecant. So just stay with me. So if I'm going this way, this would be pi over 2, pi, 3 pi over 2, and then 2 pi. Going this way, this would be negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. And hopefully remember that sine has an amplitude of 1. Goes as high as 1, as low as negative 1. Okay. So, it's a good test for Friday. Where does the sine graph start, guys? 0. Where does cosine start? 1. Good. Well, please remember that for Friday, because if you don't remember that fact, your whole graph's going to be wrong. Sine starts at 0. And then just remember the sine wave looks like that, right? So it's going to be 0, and then goes up, back to 0, down to negative 1, and then 0. Okay. I'm also going to graph one cycle going this way. So if I'm going backwards, this would be negative 1, 0, 1, and then 0 again. Okay, I don't trust myself to do this while I'm holding it, so I'm going to do it like this. It's hard to draw it when I'm holding it. Because you guys do homework like this all the time, right? You guys walking around doing math? No. Okay. I'm going to get rid of this because we already know what this looks like. All right. So what I'm going to do now is, remember, we know that cosine is going to have asymptotes at every pi, right? So I'm going to draw an asymptote at negative 2 pi, at negative pi, at 0, pi, and 2 pi. Bless you. All right, now here comes the weird part. Just think about what you guys know about asymptotes. Are we allowed to cross vertical asymptotes? No. So we know that this is a reciprocal, right? This cosecant graph is a cosecant function is reciprocal. So think about upside down. So this is how you graph the cosecant function. So do you guys see how like this kind of looks like a little hill, right? To graph the cosecant function between these two asymptotes, instead of drawing a hill like this, I'm going to draw the upside down version of that in between these asymptotes. So instead of drawing something that like looks like this, I'm going to draw something that looks like this. Okay, so it will look like they're not parabolas, but they're going to look like little parabolas in between all the asymptotes. So in order to graph that, do you guys see how we have that point already right there? All you're going to do is graph that little U, and it's going to touch that point right there, and then come back up like that. And you're going to do the same thing for all the parts. So right here are hills like this. It looks like it's opening up, so it's going to open down right there. And then it's going to open up. And open down. Okay. So No, you don't have to graph the purple every time. That was just to show you guys where it comes from. Okay, so when you guys really graph it, it's gonna look like that, just the blue. Okay, but I'm gonna put it back because that way it's in your notes. But so just understand that we're just graphing the blue when we're graphing this normally. Okay, so just like the sine graph, the cosecant graph has a period of 2 pi. So basically, the period is going to have one little u that's facing up and one little u that's facing down in one period. Okay? So that being said, if I'm graphing the cosecant function, do you guys agree that 0 would be a good place to start? 0, and then I have 1 at pi over 2, asymptote, 3 pi over 2, I have -1, asymptote. So I really just have 2 points in my table and 3 asymptotes. So these aren't that hard to graph, it's a lot to remember. Okay? Questions? Okay. One more. Secant. Same idea. So remember that the secant of x is a reciprocal of cosine x. So this means that this graph, why do I keep doing that? The secant graph will have vertical asymptotes at any point where cosine of x is equal to 0. What other function have we studied that has cosine on the bottom? Tangent. Where did tangent have asymptotes? What? Every pi over 2, but what specifically, what type of pi's over 2s? Odd. Good. So every odd pi over 2. So in order to help us graph this a little bit better and understand where it comes from, what we're going to do the same thing. We're going to graph the cosine function and then use that to help us graph secant. Does anybody have any questions so far? You guys okay? Okay. Sometimes I just ramble. I want to make sure you guys are good. All right. So every odd pi over 2. So we'll deal with that here in a second. Let's graph cosine first. Where does cosine graph start? At 1. So remember, the cosine wave looks something like that. So it's going to go 1, 0, -1, 0, and then 1. So this is one period. I want to graph one more period going this way. So if I'm going backwards, it's going to be 0, -1, 0, then 1. That look okay? For standing up, that looks okay? All right. Thank you. Thank you. Appreciate it. Okay. So we're going to graph asymptotes at every odd pi over 2. Oops. So it looks like I have a downward facing U right there. So that means like right here, I'm gonna have an upward facing U. This opens up. So I'm gonna open down right here. Open up. Open down. It's gonna open up. If I kept going, you guys agree like I could draw that part, right? I'm just gonna stop though. So if I'm trying to make my life easier to graph this for like a test, homework, whatever, is it smart to start at 0? Because you guys see how it's like half of a U? So I actually would start right here. Because if I start from here to here, do you guys see how I have one open and one opens up and one opens down? So this could represent right here from here to here. Hey. One period. Thank you. Okay. Questions? Okay. Do you guys have... Wait, just kidding. Just kidding. All right. Let's do one graph of cosecant, and then we'll do one graph of secant, and then we'll be done. All right. Is there going to be a period change? No, because there's no number directly in front of the x. Okay, so what's the period going to be then? 2 pi. Good. The period's going to be 2 pi. All right. So looking at your notes, guys, when we sketched it together, where would be a good place to start the table for cosecant? Don't look at me, look at your notes. 0, good. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now, where did the cosecant graph have asymptotes? At every pi. So asymptote here, asymptote here. Oh, just kidding. Asymptote here and asymptote here. So think about this. This is the reciprocal of sine, right? What's the sine of pi over 2? 1. So if I take 1 and flip it upside down, guess what, guys? It's still 1. The bottom of the unit circle, what's the sine of 3 pi over 2? -1. So if I flip that upside down, it's still -1. Do you guys see what I'm saying? Because it's the reciprocal. So the numbers aren't going to be crazy. That's why I chose these numbers on purpose. Okay? So we know what that looks like. So now to graph the other function, y equals 2 cosecant of x minus 1. Okay, did our period change? No. So are my x's going to change? No. So same x's. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Asymptote, asymptote, asymptote. Do you guys agree that the 2 and the -1 means to multiply all the y's by 2 and then subtract 1? Okay, so if I multiply this by 2, I get 2. 2 minus 1 gives me 1. That's weird, it didn't change. If I multiply this by 2, I get -2. Minus 1, I get -3. Okay? So our graph's gonna look something like this. I'm gonna plot a point here, plot a point down here, okay? The graph is not a reflection, right? Because it's +2. So do you guys agree if I graphed a sine wave, it would look something like that? So since it's gonna be like this at the beginning, that means that if I'm doing the cosecant graph, it's gonna be the reciprocal, so it's gonna look something like that. Right there. And then same thing down here, it's gonna look something like that. Okay, domain and range. Where are all our asymptotes happening? At every pi, right? Do we care if it's odd? No. So we're not discriminating here. Every pi. Doesn't matter if it's even or odd. So the domain of this thing is going to be all x such that x cannot be k pi, where k is an integer. I know I didn't write and. I'm just being lazy. All right, the range is different, so pay attention. The range is not all real numbers. Because, do you guys see how, what's the y value right here? 1, and then it's going all the way to infinity. What's the y value right here? and it's going all the way towards negative infinity, right? So do you guys see that between -3 and 1, there's nothing that the graph's touching, okay? So that means when I write my range, what symbol do I have to include in the range? A union, because I'm skipping all this crap. There's nothing in between that the graph is touching, okay? So start with the lowest number. So do you guys agree the lowest number would be negative infinity? So negative infinity all the way to -3. And then union 1 to infinity. Okay. I feel like you guys, if anything on these problems, you guys just need just the practice and the help with how to set this up. Once you guys set this up, do you guys agree the graphing part's pretty easy? Okay, so for this last problem, all I'm gonna do is help you guys set it up. I'm not gonna do the actual graph though, because I feel like once from that point, you guys are good. Okay, that way, because I wanna give you guys work time too. All right, so last problem, we're gonna do one secant graph, and then we'll be done. Is there going to be a period change? Yes. Okay, so what number is going to tell me to use to help me find my period? The 2, right? So the period normally is 2 pi. So to find the period of this function, the period is going to be 2 pi divided by 2, which is just pi. Once I have this, to find my scale, what do I do with this? Divide by 4. Cool? Now, secant. Look at the secant graph we did. Where would be a great place to start the secant table? Negative pi over 2. Because think about it. This has cosine on the bottom, and didn't we do the tangent table too? We start at negative pi over 2. So for secant x, start at negative pi over 2. And if I keep going by pi over 2 is 0, pi over 2, pi, 3 pi over 2. And remember, secant has asymptotes at every odd pi over 2. All right. Secant is a reciprocal of cosine. What's the cosine of 0? 1. So guess what? The secant of 0 is also 1. Yay. Cosine of pi is negative 1. So the reciprocal of that is also negative 1. Okay. So your professor is a nice guy, and he's not going to make you guys move left and right for these. So do you guys see how we have that 0 as like kind of like our baseline? It's a second value in our table. We want to keep that as our second value in the transformation, okay? And then I'm going to use my scale, because you guys see how I have one number before 0 and then some numbers after 0? I want to use that scale to find this value. So I'm going to subtract my scale from 0 to get the point that would be 1 before that. So do you guys agree that'd be negative pi over 4? And then I'm going to keep going. So I'm going to get pi over 4. This would be pi over 2. And then 3 pi over 4. Okay, if I measured from here to here, that would be pi, which is my period. So that's correct. Okay. Now, how am I going to get my y's? Multiply by 4 and add 1. Good. So asymptote, asymptote, asymptote. I want to make sure everyone's cool with that. Do you guys see how asymptote, asymptote, asymptote? So the new table will still have asymptotes in the same place. First, middle, last. Okay? Multiply this by 4, we get 4. Add 1, we get 5. Multiply this by 4, we get negative 4. Add 1, we get negative 3. Okay? You guys do the graph. It's excellent. We're happy. Domain and range. Do you guys agree that the graph's going to look something like that, right? So what value would this be? 5, and this value would be negative 3, right? So that's going to help me with my range. The domain, what do all these asymptotes have in common? They're all pi over 4, but they're also what type of numbers? Odd. So the domain would be x cannot be, all x, such that x cannot be k pi over 4, where k is odd. And then the range, this right here is going to go 5 to infinity. This is going to be negative 3 to negative infinity. I just said it backwards. So the range would be negative infinity to negative 3, closed bracket. I didn't talk about this. We're okay with it being closed bracket, right? Because it crosses at that point, okay? Union, bracket, 5 to infinity. Okay? From there, I feel like you guys are okay with doing the graph on your own. But this is, if you don't have this information correct, do you guys agree that it's hard to graph it, right? Correctly?